All right, so no like notes today. We'll just jump in and do some of today's assignment together. And you look, doesn't have a back, so it's just those 12 problems. But yeah, let's start with number 1. There's a less than sign. That means I want all my y's to be less than or below this graph. I'm going to shade everything below the graph. So job 1 is just do the graph, and then we'll worry about shading. So let's see, x minus 4. I can pick on people for this. X minus 4. Angelina, what does the minus 4 do to the graph? Good, right 4. Oof, this is a smaller graph than yesterday. Right 4. And that's the only transformation that has happened to this graph. So then I can do the V. Before I draw the line in, do you remember solid line versus dashed line?
Yes. Solid line is included.
Correct. Solid line means we want to include it. It's sort of the equivalent of a parentheses, right? We don't want to include the line for this one because it's not included. So if it's equal to, then that would be a solid line. If it doesn't have the equal to, then we'll use a dashed line. Oops. Again, solid line is sort of equivalent to a bracket, equivalent to a closed circle. We want to include the line. If we don't want to include the line or the point, that's the parentheses, the open circle, the dashed line. I think this one's easy to keep straight because it sort of matches the open and closed circle thing. There's less to a dashed line because we don't want to include the line. A solid line, we would want to include it. So, dashed line. Less than means below. So we'll shade below. And you don't have to play blackout with an ink pen or anything. You can just lightly shade with a pencil, or draw some lines underneath, as long as I can see that what's been shaded. And that means that anything below the line, anything that's shaded, would be a true statement, would make this statement true. So you pick any point you like over here, I don't know, let's just try -3, 0. And let's see if that works. It should work because it's in the shaded area. So I plug 0 in for y, -3 in for x. Let's see, -3 minus 4 is -7, but absolute value makes it positive. 0 is less than 7. Yep, that's true. So, again, the shaded area is the region of solutions. The not shaded area is no solutions. Which else do we want to work? Oh, they're circled right there for me. Number 4. What makes number 4 a little different than?
Fraction.
Well, you know what? Let's let you have a chance to work one of the greater than, equal to things. You try number 5. Try number 5. 2, 3, 4, 5 over 1. 5 over 1. So yeah, very steep V. At least I need to think about this, especially when I'm using a pen. Before I sketch that in, do I want a solid line or a dashed line?
Solid line.
Why a solid line?
Because it's square root of equal to.
Good, the equal to thing. So I do want a solid line because of the equal to part. Alright, there's my steep V. And Jordan, should I shade above the line or below the line?
Above the line, sir.
Why above?
Because it's greater than.
Perfect. Greater than means shade above. And so kind of a filled in V here. Okay, looking around, looked like most of you had that. So that's pretty good. That's a lot of pieces there. Two transformations. You had to think about solid versus dotted. You had to get the shading correct. So pretty good on that one. Let's look at 4. So what's weird about 4? Like, yeah, the 2 and the 1/2. Like, what the heck? Because the 2 seems like it would be a vertical stretch, but the half would be this way, but it's backwards. So
It's just X.
You can distribute a number into or out of, if you need to, an absolute value. Don't do that with a negative because that messes things up, because absolute value messes with negatives. So don't do a negative, but you can distribute the number into or out of an absolute value. And that way, instead of having to think about a vertical stretch and a horizontal stretch, like just distribute the 2 in there. And so that makes x plus 4 minus 3. Because what we want is x to be by itself. That's a good question. So like on number 8, x is already by itself. I don't want to mess with 3x minus 6. I would rather just do the 3 as a stretch. In fact, we'd rather the number be outside because it's easier to do that way. So finish number 4. That doesn't take long now. In fact, I can probably pick on people on the fly for number 4. Samuel, what's one of the transformations that has happened?
I'm not sure yet.
So there's a plus 4 and a minus 3. I'll let Madison go first. Maybe that'll jog your memory. Madison, what's one of the transformations that's happened to number 4? So that minus 3 means we're going to go down 3. Good. So that leaves the plus 4. It's in there with x, so that means it's doing an x thing. So it has to be a left-right thing. And then the x stuff is backwards. So which way are we going?
Left 4.
Good. Left 4. So left 4, down 3. And then there aren't any other changes, so just the regular slope of 1 pointed up. There's no less than or greater than to even worry about on this one. So no shading, no dashed, just the simple V. Looking at number 6. Oh, go ahead, Ben.
Are you going to have like one of these like on your test? These tricky questions.
Yes, definitely. Looking at number 6. What do you think we should do with number 6?
Distribute the negative.
Well, you can't distribute a negative into an absolute value. That messes it up. But I could take the 2 out, and that would make my life a lot easier. So let's factor out the 2, and then it looks like I want it to look. Like I really want the x by itself. So I would take the 2 out of number 6.
Why could you do that?
Because you can take a number, not a negative, but you can take a positive number into or out of the absolute values. And you would do that because you can't tell left or right, like, or maybe I should phrase it this way. Looking at that graph, that looks like you should go, left 4? Because of the plus 4? But you can't do that unless it's just the x and a number. So you take the 2 off. So you have to take the 2 off to know how many left or right to go. That's a better way to say it. X has to be by itself in order to know how many left or right to go. Let's see. How many, oh goodness, this is a good one. How many popsicle sticks should I draw for this one? How many transformations have there been?
3.
I would hear the argument for 3, but I would rather say 4. So when we get to Corinna, we'll see if there's one left, or if we get to all 4 before then. Brooklyn, start us off. You get to pick. You're first. Name a transformation that's happened.
Flips.
Wait, only want one. Oh, sorry. You were going to say which direction? Yeah, which way are we flipping?
Vertical flip.
And how did you know that?
Because it's
Good. So that negative makes the vertical flip. Layla, what else do we see?
why are you gonna go left too?
We are going to go left too. Hayden, what else?
We're gonna go down 3.
Down 3. And Corinna, there's one thing left.
It would be the vertical stretch of
Good.
2.
Vertical stretch of 2. Okay, that's a lot of things to keep up with. Left 2, down 3. So there's my starting point. Yeah, left 2, down 3. Flip it over and stretch by 2. So my new slope is slope kind of in parentheses or asterisk. It's not really a slope, but kind of a slope. I'm thinking about dash first dotted or dash first solid, but that doesn't matter because it's equal to. Well, I guess it does matter, but it's a solid line and there's no shading involved. And again, please double check. The mistake students make is they write all the things down correctly and then forget to do all of them. I guess because especially when there's so many, they'll leave something out, even though they wrote it down. So I know they knew they were supposed to vertical flip it. They'll have everything written and then they'll have that V pointed up, or they will forget to stretch it. So I like this one because the directions tell what transformations took place. So this one is specifically asking you to write them out. So write them out and then use them. Oh, speaking of directions, domain and range. I mean, not hard, but hey, good review. Be on the test next week, so why not? George, how about the domain for this one?
Could be -5 and 2.
Remember, there's arrows on there, so it's going to go forever to the left and forever to the right.
Could it be negative infinity
There you go.
and infinity?
Good. So like on the graph, yeah, I guess it does look like it goes from -5 to 2, but it's more than what we see. There's more to it than what we see. Mason, how about the range? So bottom to top.
Parentheses, negative infinity, -3, bracket.
Perfect. Y'all probably didn't see Mason, but I caught his hand motion right before he answered. He did this, like his brain is thinking, read from the bottom to the top, starts at negative infinity, goes up to -3, and include -3. What else do we need to do? What are you going to do on number 7? Take out the 2. That one's not bad. Let's do one backwards problem. By backwards problem, like a Jeopardy problem, like here's the answer, number 11. What's the equation? So it's using the same information, but your brain has to work kind of in reverse. So try number 11. Some of you jump straight to the answer, which is fine because it didn't say to show any work or anything. But a few of you wrote out left 5 and vertical stretch by 2 helping your brain process what's going on. So left 5 would be x plus 5 in the absolute value bars. And to stretch it by 2, I need a 2 in front. And then to make it an equation, like don't leave that, I will take off for that. It's going to be annoying if you make a 98 on the test, because what's this missing? Y equals. It's not an equation right now, so y equals. Brooklyn?
Can you put f of x?
Yes, definitely.
Okay.
Fancier, but definitely okay.
How do you know, like, how can you tell the difference between there's like a horizontal compression?
Okay. That's a great question. So why do you not use a horizontal compression for this? The first answer is it's easier to deal with vertical stuff, so let's just assume it's vertical and do that. But you're right, this could have been seen as a vertical compression. So to compress vertically, that means we need a 2 on the inside. Like that.
Where's the end of the...
Sorry. But do you see that these are the same thing?
So it could
Just that the not factor out.
Right.
So if that were on the test, you wouldn't take off from the bottom.
I would prefer you do this one, but this one is okay.
Okay.
Because they're the same. You would write this one if you see it as a horizontal compression. You would write this if you see it as a vertical stretch.
Okay.
And hopefully you realize, wait a minute, that's the same thing. But it's easier to write them as vertical, so we almost always, if given the choice, we write them as vertical.
Will there ever be anything where you would ask for a specific one?
No.
Okay.
No. Not until you get to pre-cal.
Okay.
Because pre-cal we can... In Algebra 2, it's almost always where you could kind of do one or the other. But in pre-cal we'll do things like waves. And so there, that definitely matters if we squish it this way, where it gets smaller, that's a horizontal, versus a vertical where it's just shorter like that. Again, pre-cal, not worried about it. Number 12. So yeah, that's kind of tricky.
It's hard to see where the line is.
It's hard to see where the line is. You might have to go several over and like, instead of just seeing,
Is it 1/3?
do we think it's 1/3?
Yeah.
Yeah, because it might think it's 2, but then you check the next one and that didn't hit right. So if it's 3, I think it keeps hitting on the 3. So I think that slope is 1/3. Put my glasses on to read this stuff. So you're still 20 minutes left or so. This is today's assignment. We're what, about halfway done based on just the ones we've done. So work on the rest of them. Finish before you leave and not have any homework.